Industry skills, practical knowledge, real-world impact. This is Simple Gyan.
Welcome back, science geeks. Today, we are diving deep into one of the most important, dangerous, and fascinating chemicals on the planet, nitric acid. Its chemical formula is HNO3, and historically, alchemists called it aqua fortis, which translates to strong water. Why strong water? Because this stuff can dissolve almost anything, even silver and copper. Today, we are going to break down exactly how humanity manufactures this industrial powerhouse, explore its unique physical and chemical properties, and look at how it shapes our modern world, from fertilizers to rocket fuel. Let's get into it. If you want to make a lot of nitric acid today, you use the Ostwald process. Developed by Wilhelm Ostwald in 1902, this method accounts for nearly all commercial nitric acid production. It's highly efficient and relies on the catalytic oxidation of ammonia. It happens in 3 main steps. Step 1 takes place in the converter chamber. We mix ammonia gas with excess air and pass it over a platinum-rhodium gauge catalyst at a scorching 800 degrees Celsius under pressure. This produces nitric oxide and water. Here is the chemical breakdown. 4NH3 plus 5O2 yields 4NO plus 6H2O. Step 2. The hot nitric oxide gas is cooled and pushed into an oxidation chamber. Here it reacts with more oxygen from the air to form nitrogen dioxide, which is a distinct heavy brown gas. The reaction 2NO plus O2 yields 2NO2. Finally, we send that brown nitrogen dioxide gas into an absorption tower filled with quartz pieces. Water is sprayed from the top while the gas rises from the bottom. The gas absorbs into the water to form our final product, nitric acid. 3NO2 plus H2O yields 2HNO3 plus NO. The leftover NO from this reaction is recycled back into step 2. The acid we get from this tower is about 68% concentrated. By distilling it with concentrated sulfuric acid, we can bump that up to 98%, what we call fuming nitric acid. Before Ostwald, humanity used the Birkeland-Ida process, also known as the arc process. It essentially mimicked lightning strikes to combine nitrogen and oxygen directly from the air using a massive 3000 degrees Celsius electric arc. N2 plus O2 yields 2NO at 3000 degrees. It was a brilliant concept, but it consumed ridiculous amounts of electricity, so the Ostwald process eventually replaced it. But what if you just need a little bit in the lab? You can actually synthesize it by heating a nitrate salt, like sodium nitrate or potassium nitrate, with concentrated sulfuric acid in a glass retort. NaNO3 plus H2SO4 yields NaHSO4 plus HNO3. The nitric acid evaporates and is condensed back into a liquid. Simple, effective, but strictly for small-scale batches. So, what exactly does this acid look and feel like? Let's check its physical properties. Pure nitric acid is completely colorless. However, older lab samples often look yellow or brown. This is because sunlight slowly decomposes the acid into brown nitrogen dioxide gas. It has a highly pungent, suffocating smell. It is heavier than water, with a specific gravity of 1.504. It boils at 84 degrees and freezes at minus 41.6. It is highly corrosive. If it touches skin, it reacts with proteins to form a yellow compound called xanthoproteic acid, leaving a nasty, painful yellow stain. Nitric acid isn't just an acid, it is one of the strongest oxidizing agents in chemistry. This defines its chemical behavior. First, its acidic nature. Like all strong acids, it completely dissociates in water to give hydrogen ions and nitrate ions. But the real magic happens when it acts as an oxidizer. Unlike other acids, nitric acid rarely produces hydrogen gas when it reacts with metals. Instead, the acid itself gets reduced. With dilute nitric acid and copper, it produces colorless nitric oxide gas. But with concentrated nitric acid, it produces thick, toxic brown nitrogen dioxide gas. The concentration changes everything. It also oxidizes nonmetals. It will turn solid carbon into carbon dioxide and sulfur into sulfuric acid. A fascinating quirk, passivity. If you drop iron, chromium, or aluminum into concentrated nitric acid, nothing happens. The acid is so strong, it instantly forms a microscopic layer of metal oxide on the surface, protecting it from further reaction. Why do we produce millions of tons every year? Over 75% of all nitric acid goes into making ammonium nitrate, a vital fertilizer. It is also the key ingredient in nitration reactions to make TNT, nitroglycerin, and RDX. Fuming nitric acid is an incredibly potent oxidizer, used in early rocket fuels to make them combust in the vacuum of space. It's essential for manufacturing nylon and various polyurethanes, and for etching printed circuit boards, as it dissolves silver but leaves gold untouched. From feeding the world to launching rockets, nitric acid is undeniably one of the most critical chemicals in the industrial age. Whether it's the brilliant engineering of the Ostwald process or its powerful oxidizing properties, HNO3 deserves our utmost respect. If you learned something new today, make sure to hit that like button and subscribe for more deep dives into chemistry. Drop a comment below, what chemical should we tackle next? Sulfuric acid, fluorine, let me know. Until next time, stay curious.